When we studied fractions in middle school, fractions like a over b, we were told very, very, very clearly that the denominator b cannot be equal to 0. So then when we translate the idea into functions and we study something like f of x over g of x, that's what a rational function is, okay? A rational function is basically a ratio of functions. And we are told that just as a ratio of numbers, the denominator b cannot be 0, in a rational functions, which is a ratio of functions, g of x, it's not that the g of x cannot be 0, but the values of x that make gx 0, the zeros of g of x, are not permitted into the domain of this rational function f of x over g of x. Why? Because we're told that wherever the denominator becomes 0, the function will become too large, infinite, and we learn about something called vertical asymptote. So my question is this: in a rational function where the denominator becomes 0, will there always be a vertical asymptote? Let's find out. You guessed this right. Today we are talking about vertical asymptotes, and we are looking at an example such as this, where there's a function in the numerator, another function in the denominator. These are called rational functions. I'll just write it down here, okay? This is an example of a rational function, a ratio of functions. And we are trying to answer the question, will a rational function always have a vertical asymptote where the denominator becomes 0? Okay, let's find out. So if we were to factorize the numerator, we should get x squared plus 2x minus 8 as 4 and 2, x plus 4, x minus 2. That should be the numerator. And the denominator should be 4 and 3, x plus 4, x minus 3. Am I correct? 4x minus 2x is, yeah, that's good. 4x minus 3x is, that's also correct. So in the factored form, the same function can be written as x plus 4 times x minus 2 divided by x plus 4 times x minus 3. Now, the first thing that people would notice that, hey, the domain cannot include values such as x is equal to negative 4 and x is equal to 3. And the domain cannot include these two values, x equals negative 4 and x equals 3, because as for those values of x, the denominator will become 0. If you haven't yet seen my video on finding the domain algebraically, the link to that video will be somewhere up there. Please go and take a look at it, okay? So for these two values of x, where the denominator becomes 0, will there be a vertical asymptote at x equals negative 4 and at x equals 3. Let's find out. So on the graph page, let me add a graph page. I'm going to enter the function in its original form, okay? Just because, for fun's sake. And so control division sign will give me that template for the fraction. And I'm saying x squared plus 2x. Just want to make sure that we're entering the function correctly. In the denominator, we've got x squared plus x minus 12. Is that it? Okay, now watch, guys. Watch, do not blink, all right? So I'm going to hit enter, and there we go. Wow, we do have a vertical asymptote, but hey, we just have one vertical asymptote. I thought we were supposed to have two vertical asymptotes, right? X equals negative 4, x equals 3. So we are able to see one vertical asymptote. Let's just check, okay? Let's just examine. I'm going to go to menu, enter relation. Let's just call this x equals 3. When I hit enter, that's in blue. So I'm just going to change that color so that we're able to distinguish what we're seeing. I'm going to change that to red. And now let's change some attributes. Make it a little thicker, make it a little dotted, something like that. Yeah, or maybe something like this. Okay, cool. Now that looks like an asymptote, but it says that's x equals 3. And we were able to see it even algebraically that x equals 3, denominator becoming 0, there is a vertical asymptote. But what about x equals negative 4? Let's look closer. This time, let's just go and insert a table, all right? So split screen, and this will give you the x and the y values. And you can see that at x equals 3, the function is undefined. So clearly denominator becoming 0, x equals 3 is not part of the domain. and we saw a vertical asymptote. We can see that, all right? But what's going on at x equals a -4? Let me go and on edit table settings, I'm just going to change this to ask so that it's going to be an user input. And there you go, user input, x equals -4, I want to find out, all right? So watch this, guys, very closely. X equals -4, hit enter, undefined. So the function is undefined because x equals -4 cannot be part of the domain. It's in the denominator, but yet at x equals -4, we are not seeing a vertical asymptote. So what's going on? Let's remove this table. Clearly, you can see that this is -1, -2, -3, -4. There is no vertical asymptote. The function is also not defined, and that's in the denominator as we saw in our algebraic working. So let me try and explain what's going on here right now. You see, I'm just going to draw that portion of the graph, okay? So I think it was something like this. There was a vertical asymptote at 3, and let's just draw a vertical asymptote at 3, and the graph, let me draw that in, there's a, okay, that's 1, so it's going through this. So I'm just going to draw the graph this way, and it's going on like that. And if this represents the point -4, basically, watch, it's not defined at x equals -4, right? So what's happening here? There is a hole in the graph. That value, f of -4, is not defined. There is a hole. There is a hole in the graph at x equals -4. That means every value of x, for every value of x after -4 to the right hand side of -4, and for every value of x before -4 on the left hand side of -4, there is a value of the function. Okay, the function takes some value before and after -4, but at -4, the function is not defined. There is not a vertical asymptote, but there is a hole. So the question is, how can we tell whether the function has a hole or a vertical asymptote without using a graphing utility? Let's find out. You know, in this question, let's take a look at these factored form. We have a vertical asymptote at x equals -3. That's fine. But what about this factor that's creating a problem in the denominator? There is an x plus 4 on the numerator and on the denominator. Can you see that? The same factor, x plus 4, which was creating a problem in the denominator, and x equals -4 because of that was not part of the domain, that same factor is appearing on the numerator. And we know that algebraically, we can actually cancel those common factors. That is the reason we don't have a vertical asymptote at x equals -4. There is only a hole in the graph. Let me summarize it this way. When you have a rational function, which means f of x is equal to g of x, and let's just say that we can factor it, okay? The factors of the numerator being x minus a, x minus c. If it can't be, that's a different story. But if it can be factored, x minus a, x minus b, and the factors of the denominator being x minus b and x minus d. I don't know why I wrote it as c, but never mind, let's go with it. When the factors are different and there's no common factor, this would mean that we have vertical asymptotes at x equals b, x equals d, because x equals b and x equals d are not going to be part of the domain of this rational function. However, if one of these factors, if this was x minus b or x minus d, either way, if one of the factors could be cancelled or both of them could be cancelled, there will not be a vertical asymptote at x equals b, all right? So if you have a case like x minus b, the same factors on the numerator and the denominator, you're not going to have a vertical asymptote at x equals b. That's where you will have a hole, the factor that cancels off, all right? So let's take an example to understand this better. Here we have a question which says, for each function below, list all holes, vertical asymptotes, and x-intercepts. In this video, we are talking about holes and vertical asymptotes. We'll come to a mixed bag of questions on some other video, all right? So the first example, f of x, is defined as x minus 3 times x plus 2 on the numerator, x minus 3 times 2x plus 1 on the denominator. And as you can see, algebraically, this factor, x minus 3 can be cancelled on the numerator and the denominator, which means that at x is equal to 3, there is a whole, not a vertical asymptote, all right? But 2x plus 1 remains, that factor in the denominator 2x plus 1 remains, and we can say that at x is equal to a negative half, there is a vertical asymptote. So yes, x equals 3 and x equals negative half do not belong to the domain. That's why the function is not going to be defined at those values, but you're going to have a vertical asymptote only at x equals negative half, because that's the only factor that remains without getting cancelled out with any of the factors from the numerator. Okay, now let's look at question number 3. All right, see, it's not factored. And the first thing I will always encourage you to do is first factorize. So there's a cube, x cubed minus 12x squared plus 32x. Okay, so f of x, I'm going to write it as x times x squared minus 12x plus 32. And on the denominator, you've got x squared minus 2x minus 8. A quick factoring will tell me that x minus 4, x plus 2, is that right? Minus 4x plus 2x looks right. The numerator can be factored further. I just want to make sure that we can see what's going on. We've got x, and that should be minus 4 minus 8. Do we have it right? Minus 4 minus 8. Yep, looks good to me. X minus 4 and x plus 2. So the first thing to do would be to factorize the numerator and the denominator, okay? Now, when you factor the numerator and the denominator, you'll be able to see that there is a common factor in the numerator and the denominator. That means the function is not defined at x equals 4 and at x equals negative 2, but it behaves differently at these two values, which means at x equals 4, there is a hole in the graph, but at x equals negative 2, there is a vertical asymptote. So what did we learn today? That whenever you have a rational function of the form f of x over g of x, the domain of this rational function, y is equal to f of x over g of x, will not contain the values of x where g of x becomes 0, correct? Okay, but that does not mean that for those values of x where gx becomes 0, you will always have a vertical asymptote. Check with the numerator. If factors of the numerator cancel with those factors of the denominator, you may have a hole in the graph. If you have gained any value from this video, please do not forget to like, share, and subscribe. I'm going to see you in the next video.